All right. Hello everyone, I'm Steve, and I am PhD candidate in the Department of Physical Education and Sports Sciences. Let's move on to the master's session. In the beginning, we did consider a different kind of approach to solve this kind of problem or issues. However, we did face the modeling dilemma. Why not ordinary logistic regression will not apply to those approach? We did attempt ordinary logistic regression since the salary data is naturally ordered. However, this kind of analysis have some kind of assumption violation. The model relies on the proportional odds assumption, which means that the relationship between independent variables and the log odds is constant across all cut points. Since that, the test result shows that the assumption was rejected. So it has some kind of potential implication, that is the impact of those different kind of variables. For example, like Python skills on the salary is not uniform across different kind of salary levels. It suggests that complex nonlinear relationships. So we trying to figure out what kind of methods or approach that can be utilized to this analysis. Thanks to the Grandmaster in Machine Learning, Chen and Liu Xiang, we did find out some kind of resolution or a solution that is a regression tree called. The master's selection, we adopted the regression tree approach implemented via some kind of procedure in sets. This kind of model, they have some kind of comparative advantage. That is, it's a kind of non-parametric analysis. What I mean by that is it doesn't require normality or linearity assumptions. It has automatic interaction detection. So it's capable of capturing complex interactions between those variables without manual simplification. However, it also has some kind of limitation. That is the overfitting risk. With more than 100 categorical variables and high continuity, which means many options, the tree can grow to complex, which means that it will capture noise instead of signal. And the curse of dimensionality is that too many features dilute the model's predictive power. So we did have some kind of transition, that is the necessity of rigorous feature selection process before final modeling. So how can we overcome those overfitting risk? Well, so we utilize the lasso feature selection. The master lasso, which acronym is the least absolute shrinkage and selection operator. It applies a penalty term to shrink coefficients of less important variables to 0. So the result will be like this, that it drastically reduced dimensionality from more than 100 variables to 6 key predictors. And you also selected variables like the country, experience, and spending, and etc. So its benefit is that it enhances model interpretability and generalization, and you pretended a tree from memorizing to the training data. So we can see from the method process from this figure, from the beginning, the raw data, and we did have some kind of process, for example, like the data processing, feature selection, and model construction. And in the last process is a model validation. And finally, we can get a robust core model. Okay, let's move on to the result section. After the analysis of this kind of lasso method, we did have 6 key predictors selected by the lasso. The first one is the geography, and the second one is experience, and third one is resources, and the fourth one is a maturity. The fifth one is role, and the last one is the skill. Seems that we can observe from this table that is those 6 key predictors around all those different kind of variables. And it has some kind of specific condition and meaning. And it also has some kind of business implication in the further discussion session. And in this session, we also have the model diagnostics. We consider the validation strategy, that is the robustness over the memorization. What I mean by that, the master is included 5-4 cross validation, and the litmus test is compared to different kind of ASE comparator. So we did have some kind of a comparison between the training data and the validation data. So in this kind of comparison, the gap is minimal. It is around 15% differences, and this confirms that model is learning, not memorizing. It has successfully generalized the results, and it also has some kind of feature importance. That is based on the regression tree splitting logic. We identify a clear priority order for higher compensation, and it includes 3 steps, and we can finally get to some kind of insight. That is, to reach the peak salary, one must be a veteran leader. What I mean by that is the leader must be over than 20 years with budget authority in the USA. And the final model performance we can see from the scorecard. That is explaining the balance. What I mean by that is the accuracy. We can see from this figure on the right side, that is the right R squared is 84.87%. So the interpretation is that our model captures nearly 95% of the global salary variation. Considering the complexity of the data, which is composed more than 100 categories, this indicates an exceptionally strong fit. And regarding the global context, which is the baseline, we compare this kind of salary to the global average salary, that is the $59,017 US per year. And we did have some kind of error analysis, which is the reality check. We realized that the mean absolute error is around the 5,900 and 696 US dollars. So we might be wondering why it's so high, because the salary data has extreme variance, which is ranged from less than 1,000 to more than 500,000. While this error seems large relative to the mean, it's small relative to the total variance as shown by the high R squared. So this model successfully separates the high versus low tiers, even if pinpoint the exact dollar amount for outliers remains challenging. So we can also get some kind of conclusion like this salary spectrum. A deep dive into the key clusters, we can get 6 clusters. The first one is the executive, which is the ceiling, and the second one is the senior expert. What I mean by that is the US leaders. And the third one is the mid-level engineers, and the fourth one is the global baseline, which is the floor. So we can see from this salary spectrum, so we might get some kind of cluster around all those different kind of variables. All right, let's move on to the discussion session.